I built this shop cabinet in my last video. Now I need to make these 3 drawers, and let me show you what I was planning for those. I designed this joint and I have no idea if it's stronger than the regular miter joint or the go-to dovetail joint. But I've already committed to making 3 drawers for my shop cabinet with this joint, so let's go find out. So I figured before building up these drawers, I would do some testing. So I made some test samples, and I have 3 different joint designs. One is just a regular miter joint, which looks really nice and clean, but maybe not quite as strong. Then I have a hand-cut dovetail, which is very traditional and very strong, which looks good. And then my squiggle joint, which is maybe more contemporary and also a little unknown, but it's got some more glue surfaces than the regular miter joint, and I think it's probably going to hold up a little bit more. I have no idea, but hopefully this squiggle spline doesn't fail miserably, because I've already committed to putting this in the cabinet for the drawer design, but we'll see. Let's go break some parts. I just need to jump in here real quick, and I realize I never really explained what the squiggle spline, for lack of a better term, is. And when you have a miter joint, you normally would enforce it with a spline, and that spline runs across the miter to reinforce the joint. So I thought if I could take that spline and turn it 90 degrees from cross-cutting the miter to the length of the miter, and then incorporate some sort of unique design. In this case, I did a back and forth or squiggle design into the miter, then cut that same pattern into the miter itself, gluing the spline to reinforce the joint, and then you get the squiggle spline design. It creates a unique design element, I thought, and that's essentially what the squiggle spline is. All right, back to the video. Okay, got the test set up here. I got a 2x4 to hold each test sample. And what I did for each one of these is I just drilled a hole, and then I'm going to take this bucket and this carabiner and attach it to each sample, and then load this up with weight. And for the weight, I just got a bunch of stones. Got 32 pounds of stones, so hopefully that's enough. If not, we'll keep adding more weight. We'll find something to eventually break it and see. Compare all 3 of them, and I think it should be interesting. I have no idea what to expect. So I got a GoPro set up here, and then my high-speed camera right here, which is just my iPhone. And then that camera should be enough to capture everything. I only got 1 shot at it, so gotta double check everything, make sure we're ready to go, and then we'll be ready to break some parts. I'm going to set these in carefully. I have no idea how much it's going to take to break that. Three rocks. 4. Little one. That was a... I don't want to jolt it. I'll slowly set them in there. These is the last of the rocks. Here's the last rock. Is it gonna break it? It didn't break. Okay, gotta go get some more weight. Okay, got a 25 pound weight here, and got a little bit smart here. I rigged up a strap to a eye hook it bolted to the ceiling, so when this thing does give way, at least this is going to catch it. It's not going to crashing down to the ground. I think this safety feature is important, and I should probably put on some safety glasses. Okay, this is a little bit nerve-wracking. Just a little. Gosh. I think I should stand over here. I'm not ready for it to break. I'm really glad I put that strap in there. Whoa! All right, there it is. Finally. Oh my gosh, that scared me. All right, let's check this out. Yeah, so it was just a clean break on the miter joint. It was really just the glue holding it. That was the only thing. I don't know how well you can see this. Okay, I got the second test set up. Everything's pretty much identical except I swapped out to a bigger bucket just because I'm anticipating more load on this joint, and this is the hand cut dovetail joint. Everything's clamped in there exactly the same. Got my safety strap on. I'll have to find my safety glasses. So that's the only different really. And then I'm going to start off with these two weights. So the miter cut joint broke at 42.5. So I'm going to add this 25 and 15. So that'll be 40 pounds right off the bat. And then we'll start loading rocks. So let's get loading some rocks. Let me get these cameras rolling. Put in the 25 pounder. Will it fit like this? No. I'm going to slowly lower that in there. 25 pounds, no problem. Okay, here's 15. So this will be 40 pounds on this joint. Slowly set these in there. Oh, it just looks like it's bending like crazy. Let's start loading in rocks. Yeah. Lean back. I think it's starting to bend the bucket handle. Oh, it's gonna go. Not nearly as dramatic as the miter joint, but ooh, interesting. Okay, got the last sample set up here, and this is the squiggle spline joint. I have no idea how this is going to go. I don't know if it's going to be weaker than the miter joint or stronger. So I'm thinking I'm just going to put a 25-pound weight in here, and then that should, I mean, it should hold that. The miter joint held 42. So this should hold at least 25 pounds, I would think. So I'm going to start off with that 25-pound weight and then load rocks in there. Okay, action. Let's load it up. 25-pound weight. Here we go. Okay, please don't break so early. I don't want you to break this early. Ooh. Should I load the 15-pound weight in there? Nah, I'm just gonna do rocks. I don't want to chance it. Oh. Whoa, that was less than the miter joint. Check that out. Huh. Very cool. I got one more bonus sample to test, and that's a new version of the squiggle spline, and that's because I wasn't too happy with the results on the first squiggle spline test. It held to 32.1 pounds and the miter joint went to 42.5. So it didn't, the miter joint held 10 pounds more about. And looking at how the joint broke, it broke cleanly on the miter joint, but the spline broke along the fibers of the spline. And that's because how I cut the spline. So I cut it out of the end grain. It broke along like splitting a piece of firewood. So I decided to reorientate the spline into the side grain like this. And hopefully that will show an improvement in the strength of it. I'm gonna get this loaded up in the test stand and we'll test it out. I'm starting off with a 25-pound weight again. Carefully set this in there. Okay. I think I see it splitting already. I think the miter joint broke already. It's relying on the strength of the spline at this point. It's going. Wow, that is interesting. So is this the strongest joint? Well, I think the test results speak for themselves, and unfortunately, no, it's not the strongest. It's actually the weakest of all that I tested, the dovetail being the strongest by quite a big margin, and then this came in at the bottom of the list. Unfortunately, but you know what? I'm not building a truck bed here. I'm building some small drawers for a shop cabinet. And the strength that I measured on these, I think it's going to be more than strong enough for the drawers for my shop cabinet. And if this was a customer project, I might have a different outcome and maybe not go this way unless this was something they really wanted. But it's for my shop cabinet and I like the design of it. So I'm going to go forward with making these drawers. So the next step is I need to lay out the drawers and start cutting those out, all the pieces, and then we'll start making some squiggle spline joint drawers for my shop cabinet. Now I need to cut a groove in the inside faces of all the drawer pieces to accept the drawer bottom, and that is going to be 1/8 inch wide by 3/16 of an inch deep. And I'll do that here on the table saw. So I've been trying to come up with an idea for a drawer pull for these, and I've been wrestling with a few different ideas. One of them was just cutting like a half round in the top of each drawer, but I don't like the idea of having a hole there. And I spent a bunch of time making a nice continuous grain lineup through all the drawers. So there's that as well. Then I have this spline that I'm using. So I thought about using the spline as a drawer pull. But with it on the sides of the drawers, I think it's just going to be too distracting, too much going on. So I need something low profile, and I could go to the hardware store and buy something, but I do have this brass bar stock and a CNC mill. So I thought about designing up a low profile pole that I could mortise into the top of each drawer and have that as the drawer pole. And so I did that. I came up with this piece. And let me show you how I made that on the mill, and then we'll come back here and mortise the top of the drawers for this pull, and then hopefully get the drawers glued up. This is where the squiggle spline finally starts to take shape. Cutting the splines is the first step, and that's done here at the shaper origin. From my test samples, I used mahogany as the wood for the splines, but for the final drawers I decided to use cherry. I thought it had a nice contrast with the maple drawer front, so I'm cutting the splines here out of cherry. I also decided to go with the end grain wood orientation for the splines. It's a lot more efficient use of material, it's easier to cut, and the side grain didn't show that much more improvement in the strength. So now that I got all the drawers glued up, I need to focus my attention on cutting the spline pockets on each corner of the drawer. And in order to do that, I had to create and make a jig to hold the drawer in the right position for the shaper workstation. Then I'll attach the drawer onto the jig with a couple clamps, cut the pocket, and then remove it and switch to the next corner. So let me get this installed on the jig, and then we'll start cutting those spline pockets on this drawer and the two other ones. Okay, got this spline cut out. Now I need to flip it over on the jig and cut the opposite corner. And the reason why I just don't move to this corner is because I have opposite and symmetrical cut files. So the splines, when it's all put together, they appear symmetrical from left to right. So at this point, this is actually where the drawer is the most fragile, with those spline pockets being cut and before the splines are glued in. So I just need to make sure I took some extra caution during the glue up and make sure I wasn't applying any uneven clamping loads to opposite corners. One wrong move here and I could easily flatten these drawers. So yeah, and I have 3 to do, so ugh. One more drawer to clamp up, and that's the long drawer. This one's a little bit different because of the angle of the clamps across the diagonals. So I came up with these clamping called 3D printed piece, and it's going to make up the difference between the spline and the diagonal of the clamp. It's just really got to hold the spline in place while the glue dries. There shouldn't be too much force on it. Cross our fingers, but hopefully we're good to go. Actually, the glue up went pretty smoothly. There was a lot to do before the glue set up, but yeah, it worked out pretty good. Didn't have any major problems, so on to the next step.